Okay, so if you've been building local agents, you probably hit the same wall that I have. You're constantly striving to have the smallest, fastest model that you can for your agents to basically run with. And there are a lot of small LLMs out there. You can get things for like 2B, 3B, 4B, etc. And often I find when I find a model that I like how the reasoning works, the tool call works, and it's all coming together with the agent loop that's working. But the issue that I run into time and time again is that the moment your agent needs to actually see something, whether that's a screenshot, a PDF, a chart on the screen, perhaps even a video, that kind of thing, you're stuck. And you've even got to call a hosted vision API, or you've got to go with a much bigger multimodal model to run everything through. And that's going to eat up your VRAM, that's going to slow everything down. So OpenBMB just dropped a 1.3B parameter vision model a couple of days ago that I think actually might help in fixing this. So in this video, I'm going to have a look at the model, I'm going to have a play and see how it actually works. But before we get to that, who actually is OpenBMB? So let's talk about them because their name keeps coming up and most people don't actually know what it stands for. OpenBMB is an open lab for big model base. It's kind of a weird name, but the whole organization is oriented around making models more accessible. And that big model based thing kind of has, I guess, changed over time because actually what we're looking at here is them trying to make a really small model for a set of specific tasks in here. So OpenBMB is jointly run by a company called ModelBest, but also by the Tsinghua University NLP lab. So this is a very prestigious university. They've had lots of good deep learning research over the years. And about 4 years back, they spun out this organization to start making models. Now, these days, mostly they ship their MiniCPM line of small models, and MiniCPM-V for vision models, MiniCPM-O for omni-model stuff, Agents CPM for agents. They've got a variety of different models and research directions that they've been going in. So while they're nowhere near on par with some of the big labs that are making open models like the Google Gemma team, etc., they've had well over 20 million downloads, and this is not sort of a hobby project to them. And the common thread through all of what they've been shipping lately is this idea of edge deployability, trying to make big model capability, but in small models and on small hardware. And that brings us back to what they released a few days ago. So MiniCPM-V 4.6, this is their sort of vision model. And the key thing, I guess, here is that it's 1.3 billion parameters in total. The architecture here is actually using a Siglip 2 400 vision encoder plugged into the Qwen 3.5 0.8b language model. The cool thing with all of this is it's an Apache 2 license, they've made the weights fully open, and because it's got a context window that goes out to sort of 262K, it can take single images, multiple images, and even video inputs here. So the temptation here is just to basically sort of say, so what? We've seen that there have been a lot of small VLMs released over the last year, and most of them are sort of good for their size. But here's the thing, on the Artificial Analysis Intelligence Index, which I think I've spoken about in the past as being one of the things that I think is a better sort of benchmark and a way of looking at these models now, the 1.3 model scores 13. So that's roughly sort of like a quarter of GPT 5.5 or something. It's not going to win the award for the most intelligent model. But the interesting thing here is that this is scoring much higher than the Qwen 3.5 0.8b and better than models like the Ministral 3B model and a number of other models that are out there. So the interesting thing here is that this 1.3 billion model is beating out models that are more than twice its size on this aggregate intelligence. And if we look at things like MMUPro, which is a harder sort of visual reasoning benchmark, it's scoring better than any of the sub 2 billion open weights models that are out there now. And don't get me wrong, this model is not going to replace something like Gemini for production where accuracy is the most critical thing. And I wouldn't be using this for things like browser use or anything like that. But I do think it's really interesting that they took what was the best open vision encoder, paired it with a very small LLM model, and put their training recipe on top here to basically perform so well. And this is the sort of pattern that I keep seeing, is that a lot of these really good little small labs are standing on the shoulders of other big labs to be able to ship really good, efficient models. Now, the benchmark models are nice, but they're not actually the most interesting part of the release. The most interesting part for me is this token efficiency story. And I think this is going to matter a lot for most people that are sort of building agents. If we go back to that artificial analysis intelligence index suite there, this model is using about 5.4 million output tokens. That's roughly 19 times fewer than the Quen 3.5 0.8b non-reasoning, and 43 times fewer when compared with the thinking/reasoning version of that model. So if you think about it, same family, same backbone roughly, and we're talking an order of magnitude or two in token efficiency. And I think this matters way more than people realize for agents specifically, because if you're building an agent loop, every tool call costs tokens. Every screenshot that you pass costs tokens. Every page of a PDF costs tokens. If your vision model is chewing through 20 to 40 times more tokens than it needs to, not only have you eaten your context budget before the agent has really done anything useful, but you're just spending all these cycles sitting there for a model to be able to get its response back. So the way I like to think about this is that this is the kind of efficiency that lets you do real context engineering. It's not just about compacting and trimming your tokens to get things into a manageable state. It's about picking the models that don't need as many tokens to be able to deliver the same result. So for me, this is really what makes this so interesting, is that sure, it's not going to be the best model at this particular thing, but when you've got 20 to 40 times less tokens being needed, for the majority of the tasks, you can basically pair this up for your sub-agents to spin off to run these kind of tasks in parallel or just to be able to do them really quickly. Now, they've also got this interesting thing of this mixed 4 times and 16 times visual token compression, which is a mode that you can switch at inference time. So 16x is what you can use for sort of video and efficiency, and 4x is more for sort of like the fine-grained image details if you're going for things like that. So you're not locked into this one trade-off end to end. Again, you're doing way better than that Quen 3.5 model, which is only slightly smaller. All right, so the deployment surface here is also really key. While I've been talking about using this as a local agentic vision model, you can deploy this on VLLM, SGLang, llama.cpp or llama, etc. They've got quantized variants in all the different standard formats that you can imagine. And not only that, they've even got example apps of sort of full edge deployment for iOS, Android, and Harmony OS. And those have got all the on-device adaptation codes. You can probably just chuck that into Claude Code and get it to incorporate it into any particular mobile app that you're already working on. So I think let's jump in and have a look at a demo of me running it locally. And I can talk about some of the use cases that you could actually use this for. Okay, so if we jump into the notebook, this model's so small it really can run on lots of different hardware. The interesting thing here is you've got a few kind of things going on. So one of them is you've got this downsampling rate. So you can either downsample to 4x or to 16x. So if you're downsampling to 4x, you're going to get more detail because the image is still quite big, etc. Whereas if you're downsampling to a 16x, the image is going to be smaller, it's going to be faster, it's going to be using lower amounts of VRAM. So you can see here, we're just using the Hung Face library for bringing this in. Just got a simple helper function for setting up, running this through. In there, you're actually passing in the downsample mode. And then we can just go through and ask something. So you can see here, okay, this is our image. And the model does pretty good at reasoning and understanding. So this is, for me, replacing some of the sort of small vision models that Microsoft put out. So they had the 5Vision model, and a couple of others that were pretty small. This seems to be either smaller or on par, but getting much better results right here. So, okay, what causes this optical phenomena? You can see we're getting back a pretty good detailed response of what is in the image and then being able to express that out here. Even if we change the sample mode, so we've got like the 16x1 versus the 4x1, And you will find, yes, that definitely the 4x one works better for things like OCR or anything that you want a more detailed pass on. And the cool thing is nowadays you could actually have this as an argument that comes back from your agent or from the model as when you're calling this as a function tool, and it could just decide that, hey, this is something about writing, I want a finer grain pass, I'm going to go for 4x here. So here you can see if we go through and actually just print out the differences, you're getting back some more details in here on the 4x. Now, really, this would show up much better if we were looking at it at OCR or something like that. So that's something that you can try. Video understanding is pretty cool. This is definitely a win for this model. If we go into this video, we can see that it's two teams. It's two teams playing football. We can see the ball going back and forth before eventually, I think one of them actually takes a shot at goal. And we've got the team names and stuff like that. We've got, details going on in here. Now, I don't think it does a really good job. If anything here, I think it does make some mistakes where it talks about that actually one of the teams scores, which is not what happens. So it does a good job at sort of describing different parts here, but at least from what I'm seeing, this is not getting a great result. All right, the model seems to be pretty good at visual question answering. So here we can see we've got a image with a bunch of fish. We're asking it, how many types of fish, and it actually can go through and list out. Now, at this point, I should point out that these ones are not doing with the thinking mode on. This is just sort of the basic non-thinking version thing in here. You can see later on, we can actually run this model with thinking on or thinking off as we go through it. Invoices. So you can do visual Q&A over invoices. What was in the invoice? Again, we don't have the thinking, but we can see, okay, what's mentioned in the invoice, etc. We can do something like this. We're testing the order receipt. We've got our query items there. You can see Coke Zero, large fries. If I ask it, okay, how much was the Coke Zero? It actually does a pretty good job at being able to get this out. I would need more testing to say that this is better than the sort of 5 vision models that I've made videos about in the past. I don't think it's any worse, though, and it is probably a third the size of those. This one I also found quite interesting. So testing sort of like a medical receipt, and you can see this is handwriting, and this is something that the vision models haven't been good at in the past. We've got a bunch of different drugs mentioned there. And you can see if I ask it, what is each medicine in the receipt and how many milligrams, it does a pretty good job at going through and extracting the different drugs. And I'm not great at reading the handwriting, but it looks like they're pretty much right. And it seems that it's certainly getting the milligrams right. We've got 75, 25, 40, just checking on that again, 75, 25, 40 in there. So you can test it on a bunch of these kinds of tasks. And you can see that if you've got something general like this video of the cars, etc., going through, it will do a pretty good job at that. Where I think with video it becomes a lot harder is when you're asking very specific questions or asking for very sort of fine-grained details in there. All right, I mentioned that it's got a thinking versus non-thinking system. You can see if we take those same kind of pictures that we had earlier and we turn on thinking, you can see now we're definitely getting sort of more detailed explanations, more longer chain of thought kind of stuff coming out of this. I don't find that that always necessarily means that it has a better answer out. So I'm not sure how much of a win that actually is for this kind of task. I think you need to test it on your own task. See here on the receipt one, if I just ask a general question, how much did I pay? We get a wrong answer out on that. If we look at the thinking, then we do get much more sort of detailed of where it itemizes each of the costs and starts to then do the math of actually putting it all together. You can see I've actually run out of tokens going through this. So what I would say is try it out yourself here. When I look at the thinking version for the video, actually the thinking does do much better in this case. We've actually got it where it's getting a more accurate result. It's getting a better description of what's going on. So It could be that if you want fine-grained stuff for videos, that then the thinking actually makes a lot of sense. Finally, you can also load this up in quantized formats, right? I mentioned earlier on in the video that they've released this in quantized formats. And the cool thing here is you can run these as GGUF if you want to run that with llama.cpp, etc. Overall, I would say that if you are doing anything with agents locally where you need some kind of vision task, this is definitely a model that's worth checking out, worth running your own evals through it and seeing. And it will take a little bit of fine tuning to work out what stuff you should be using, the 16x downsampling versus the 4x, what you should be using, the thinking versus the non-thinking. There are a lot of levers going on here that you can actually sort of pull and change, but definitely worth checking out if you are looking to sort of do vision stuff and where you perhaps want to use a model that doesn't have multimodal abilities for the general text and just use this when you actually need to run an image, etc., through it. All right, let me know your thoughts in the comments. Are you looking at doing more sort of local agent stuff like this? I'm definitely looking more at this lately as the small models get better and better at this kind of task. How can I just leave these things on running locally for doing different kinds of analysis and stuff like that? Anyway, as always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.